This is the remediation help for 7.3 Part B, which is where we're graphing logarithmic functions. Now in Algebra 2, we graph pretty basic ones, and we're just going to talk to you about, typically they're base 10, sometimes base E logarithms. When you move on to another math class, you'll be graphing other types of logarithms. So what are the transformations? So we're talking right, left, up, down. Where's the vertical asymptote? We'll talk about that in a minute. The domain and the range are things that I'm going to have to ask you to answer for me here. So one of the things I notice here on this particular logarithm is we have a transformation right there. That would be a right 1, because anything in with the x is horizontal and does kind of opposite because of the built-in negative. And then there's a plus 5 over here, which means everything has been shifted up 5. So generally, a common logarithm looks like this. And this is the one time in your life where your oops, my pen's not working. Where your calculator does not do a very good job of graphing this logarithm. It almost makes it seem like it stops. And it doesn't. It's a pixel issue. Like it's trying to graph really teeny tiny points and it just kind of gives up. So what's happening here is typically you have an asymptote on the y-axis, a vertical asymptote this time, which is very different from our exponential. But the vertical asymptote is technically at whatever line is true for x equals h. So h being the horizontal shift. So our guy, who was shifted right 1, means that you have an asymptote, a vertical asymptote, at x equals 1. So what I like to do is take a highlighter, and hopefully I'll choose the right one this time, a thinner one. And at x equals 1, I'm going to draw a little line. It's supposed to be straight. It's going to fix it for me. Yeah, there we go. And that's really to help me more than anything. Because when I go to my calculator and I ask it to graph this function, hold on, graph it. X minus 1 plus 5, huh? All right, calculator. So log, down here, and then x subtract 1, close the logarithm before you plus 5 on the end. That is not at all what this guy looks like. And maybe I'll go to my table and I'll try to find some points. After the errors begin, I see there's a point at 2, 5, and then like a whole bunch of points that I'm not real excited about. And if you keep scrolling, you'll probably find one more point out there. 11, 6. So I don't really have a whole lot to work with. 2, 5 was it? Oh boy. And if I just cheat off my calculator, you know, this is what kids are graphing for me, and this is why I gotta count them wrong. You have to be smart. Oh boy. You have to be smarter than the, oh jeez, the calculator. You have to know that the tail swoops along the vertical asymptote there and continues down. I really need you to exaggerate that point, because if you don't show me that graph with your understanding of what's going on there, you're going to lose a concept error on that question. So domain and range, old topics, but a new function. This is interesting because the domain is going to kind of start at 1, but because it's got an asymptote at 1, it has a parenthesis. And this time the range is the one that goes forever, negative infinity to infinity. Remember, these are inverse functions to exponentials, so everything you know about exponentials, you got to think reverse. So a couple things to point out to you. The right 1 shift, the vertical asymptote, the domain. They all have something to do with that 1, and they all should go together. They're really the same idea. So keep that in mind when you're graphing logarithms. And there's just 3 more examples for you to do. I don't feel like I need to do any more. Just be aware that your calculator, as cool as it is, does a really bad job with graphing logarithms. All right, good luck.